Okay, everybody. So this is going to be about practice number 2. And in practice number 2, what we focused on were angles or projectiles being launched at an angle. So what we're looking at here is we're looking at the few problems that we did in class, and we're going to go in the order that we did them in class as well. So we started here with Jack be nimble, Jack be quick, this particular question. So in case you're wondering where we are in your workbook, we are at page 111, and this is the very first question there. Okay, so this question says he's jumping over a candlestick with a velocity of 5 meters per second at an angle of 30 degrees to the horizontal. So 30 degrees, 5 meters per second. Does he burn his feet on the 0.25 meter high candle? So what we want to know is how high he jumps. That's the ultimate question because we want to compare it to this number here, this 0.25 meters. Okay, I find it very helpful if you draw a picture of what is going on. So what I want to remind everyone is that we are looking at launching and landing on the same level. And also, of course, that's the peak of flight right there. Our velocity is 0 in the y direction, and it is also half the time at that point. And this, I'm going to change colors here so we can see it. So this 5 meters per second is right there. It's that point exaggerated out so we can see what is going on when it comes to our projectile, right? Because we are moving left to right, we are also moving up to down. And that particular type of a drawing should look a lot like mops when we're doing that. So, if you recognize those pictures where you get the dots and you have to, do the arrows on each side, that has to do with the vectors. That's what's going on there, right? We know our horizontal will always stay the same because we are not accelerating in the horizontal direction. So all of those arrows would look the same. And then our velocity in the y will change. It'll slow down on the way up because it doesn't go out into outer space. And then he stops at the top. And on the way down, these will look, as long as they're in the same spot on the axis, these will look identical to each other, just in opposite directions. Okay, so what do we have going on here with this guy? First thing we're going to do is a little bit of trigonometry, right? We're going to figure out our sine and our cosine piece. So this is going to be the cosine of 30 times 5 meters per second. And when you do that, you get 4.3 meters per second. Don't forget units. I noticed a lot of naked numbers, and that is a problem because then you don't know what the heck they stand for. So don't do that. All right, so sine of 30 times 5 meters per second gives us 2.5 meters per second, and that's a handy one to know. All right, this particular question is focused primarily on the vertical because we want to know how high he jumps. So it's logical to start with a VY graph, a VY time graph. So we know if we look at something that has this sort of a shape and a pattern to it, that the highest he can jump is right smack in the middle. Right, so we need, we need that height to be 0.25 or greater. Well, actually, we need greater. We don't want it to be 0.25. It'll knock the candle over. So starting with an initial velocity of 2.5 meters per second, and he's going to go, that's the peak of flight. He's slowing down on the way up. We have an acceleration of negative 9.81 meters per second squared, and we want to know the area under the curve. Okay, so that's our goal. We can use slope and we can use our area formula for that. So I'm going to start with slope. Slope is negative 9.81 meters per second squared. It is equal to the final velocity minus the initial velocity over the final time minus the initial time. Remember, you want to expand this out because in this case, the final velocity is what is 0, not the initial velocity. If you're having trouble with your negatives, that's probably why. So 0 minus 2.5 over our initial time is 0 because we always start from the beginning and we're looking for our final time. So when you cross multiply or you multiply both sides by TF, you're going to get negative 9.81. TF equals negative 2.5. The negatives are now naturally going to go away and you're going to get a TF of 0.255 seconds. That is to the peak of flight. All right, so 0.255 seconds goes then on our triangle, and now it's time to do the area of that triangle. So how high can he go? That's going to be the base, which is 0.255 seconds, times the height, which is 2.5 meters per second. And he's going to go 0.3185 meters. That's higher than 0.25, so yes, he makes it. Ta-da! There you go. All right, so hopefully that one was pretty easy overall in class. Everybody seemed to have that. Didn't take them too long to figure that one out. So let's move on to the next one. This one is number 9, and this is what the second question that we did. All right, so this guy's jumping over puddles. Again, we're dealing with an angle. Right, it says he leaps off the ground and he has a component of horizontal velocity. The fact that they say the word component tells me that it's not a horizontal projectile. It's somebody who is going like this, and their horizontal component, or the leg of the triangle, is 3 meters per second. We have no idea what that is. We have no idea what that is. We have no idea what the angle is. All right, but we do know this. Okay, and we know that the puddle is 1.5 meters long that he wants to clear. And we know that the vertical height that he travels is 0.2 meters. And we want to know whether he manages to go this far. Now, don't be fooled. A lot of folks then will take this number and try to plug it into a whole bunch of stuff. But the idea is you have to figure out if your answer is greater than or less than 1.5. So this is a comparison number for us here. We're going to just compare things. You're not going to go ahead and do a bunch of equations with it. All right, so watch out for that. This number, on the other hand, is how high he can go. So this is a number we can use. So let's go to our Vy. Well, actually, we can do both. Let's do both. I'm going to put Vx on here because we do know that this is 3 meters per second, even though we don't know his time in the air. But we do know he's starting somewhere up here, and he's going to go, and then he's going to come back down. He's going to go up, pause right there where the velocity is going to be 0 and the time is going to be half of the time, and then he's going to come back down. These two triangles will match. All right, we also know the value of that triangle is 0.2 meters. All right, so this one's negative 0.2 meters. Not that we need that for the question, but we know that information. And we know again that the slope is negative 9.81 because he's in free fall. The only force acting upon him is gravity. Now it's time to figure out, let's figure this out. All right, so let's start with what we know. We've got the slope formula, negative 9.81 meters per second squared equals Vf minus Vi. Tf minus Ti. Ti drops out because our initial time is 0. Our final velocity is 0 because that's our final velocity right there. So negative 9.81 equals negative Vi over Tf. Now we're just going to cross multiply or get Tf out of the bottom. 9.81 Tf is negative Vi. Obviously my negatives can just go away and I'll just make them positive, and that's just fine. All right, still not too close to an answer here. So now it's time to use our area under the curve. We're going to use that first triangle because that's the one we know. Well, that's the one we need. That's the one we need. Okay, so the base is going to be Tf. The height is going to be Vf, or I should say Vi. Sorry, let's see if I can erase that. Whoop. Without erasing everything at the same time, that would be good. So as you've done a million times before, you're going to slap that in there. Okay, so actually I'm going to change colors because now it's starting to get it's really starting to look all the same, and I don't really want that to happen. Okay, so I saw a lot of math mistakes. You're going to multiply both sides by 2 to get rid of that 1/2. You're not going to multiply this side by 1/2. That is just bad math right there. So don't do it. All right, equals T, or oops, I'm causing my own shadow here, so I can't see what I'm doing. Oh, teacher problems. Okay, let's try that again. Right, 9.81 Tf squared. Divide this by 9.81. That'll be my Tf squared. and I'm going to get, in the end, when I do the finish up the math, I get 0.202. So right here, 0.202, that tells me that this time is 0.404 seconds. Now, that is the time he moves left to right, just as much as he goes up to down. So now if I figure out the area under the curve by multiplying the two of those together, right, delta x equals 3 meters per second times 0.404 seconds, I'm going to figure out that he can go about 1.2-ish meters, which is less than 1.5. So this guy is going to have wet socks all day. Alrighty, so that's how we solve that particular problem. Those two are pretty reasonable. And even though I just want to point out, even though I had all of this sitting over here, it turned out I didn't honestly really need it. And sometimes that does happen to us, of course, you know. You think you've got everything you need, or you've got to go in one direction. And it doesn't matter if you can't see where the answer is. You just need to keep on going with whatever you have to work with. And then, you know, eventually circle back and say, okay, what do I have? What do I need? Where do I go? And hopefully we figure it out from there. So the last question had to do with this one, and this is where the bell rang for everybody, and it is the most complicated of all the questions here. So I have it actually on several slides, the same question, because I have a feeling this is going to take a little bit of time. That's all right. So as we read this particular question, all right, King Arthur's knights fire a cannon from the top of the wall. They give you the speed, they give you the angle, and then they talk about a second cannonball. This part here, this is really important. All right, it drops into the moat below. All right, so I'm just going to draw myself a quick picture. So here's this castle. And there is 50 meters per second, angle of 30 degrees. But then there's, so this cannonball, if you think about it, is going to go like that. I don't want to take up the whole slide, so I'm sure it'll be more than that because it's a pretty fast one. But then they said that there's an accidental cannonball. So let's say it's like right here, right? And this one just falls to the ground, all right? And that takes 1.5 seconds. So why is that information going to help? That information is actually going to do quite a bit for us. We are going to be able to figure out how tall this is based off of that. So I'm going to actually begin with the dropped cannonball. Now, some folks make the mistake in thinking that this 1.5 seconds means that as this happens, it takes 1.5 seconds to fall to the ground. That's not true, because there's a difference between this ball over here and this ball over here at this point in flight. You know, when you drop something, the initial velocity is 0. But over here, it's going to be, actually, it's going to be at negative 50 meters per second. All right, now that's a combined velocity, right? It's x and y, but it's not 0. So this is going to move. This is going to be hustling. This drop for this second half here is going to be less than 1.5 seconds. I don't know how much it is, but it's not 1.5, because that would be if it had no velocity to start with. So I'm going to work with this information first, and I'm going to figure out how tall the castle is, because that's going to help me. The height is going to be the same on this side. Okay, so here we go. Let's figure it out. Let's start with the dropped ball and figure out how tall the castle is. Now, if you drop the ball, its initial velocity is 0, and it looks like this. It's not starting in the first quadrant. It's starting in the fourth. All right, we've got this. We know that the time is 1.5 seconds. Okay, so what we can figure out right away, we can use the slope formula. And we can say, all right, VF minus, okay, that's not supposed to be negative VF. That was just me being a little too fast and fancy with the pen. All right, so VF minus VI over TF minus TI. TI is 0, VI is 0 in this case, and my TF is 1.5. So negative 9.81 times 1.5 seconds will equal VF. And when I do that math, I have it here, I promise. I just can't figure out what I did. Oh, there it goes. Negative 14.7 meters per second equals VF. All right, now that I've got that, I've got the length of this side is negative 14.7. Ugh, that's messy. I don't know if I'll be able to do this though. Let's see. We'll try. We'll try. It's tight quarters. Meters per second. All right, let me figure out the area under my curve. That will tell me how high the castle wall is. So delta y equals 1/2, 1.5 seconds, negative 14.7 meters per second. And I'm going to get about 11, well, negative, right, because it's going downward. 11, I rounded it to 11.0, quite honestly. All right, so the height is going to be 11 meters, and that's going to help me out, all right, for my next step of the question. Okay, but at this point now, I've gotten all the information I can possibly get out of the dropped cannonball, and it is now, besides that 11 meters, completely irrelevant to the problem. So let's move on. Let me redraw what I've got going on here. All right, I've got my castle wall. It is 11 meters high. We are shooting at a 30-degree angle. We've got 50 meters per second. And now let's talk about, again, a strange looking parabola there, but you get the idea. All right, now let's start talking about what's happening with this angled projectile. That will help us out. Okay, first things first, let's do a little trig. So, figuring out my initial my Vx and my initial Vy. Vx is going to be the cosine of 30 times 50 meters per second. I need that information. My initial y is going to be the sine of 30 times 50 meters per second. All right, that one's going to be 25 meters per second because the sine of 30 is a half. And this one is going to be 43.3 meters per second. Yeah, that's what that one's going to be. All right, so let's draw a Vx graph. Ultimately, what am I trying to find? I'm trying to find how far from the castle wall does the fired cannonball hit the ground. So this is my ultimate goal, is to figure out delta x. And I'm partway there because I know 43.3 meters per second. The problem is I don't know time. And that's where my y velocity is going to come in and help me. Okay, so that's ultimately what I want. I want to take the 43.3 and I want to do Vx times time in order to find that. Now I need to do the y velocity stuff. So actually what I think I'm going to do is I'm going to go forward I'm going to go on to number 5 and then I'm going to work my way backwards. All right, so I'm going to switch this. And now let's take a look at it from the Vy perspective. Okay, so my initial velocity in the y, according to my work, is 25 meters per second. And this ball is gonna, like we've said, it's gonna go up and pause, right? So that corresponds to this. And then it's gonna turn around and it's gonna go, but in this case, it's not just coming back down to level, it's gonna keep going to the bottom. It's gonna go this extra 11 meters to the ground. What this means to me is I'm gonna have a big giant old triangle over here. It is bigger than my other triangle. And this is, part of this triangle is going to match this one. And the rest of this is 11. That's the 11 meters down. So what I was showing some people on their papers as they were working is, okay, I got to figure out how high it goes. That's up here. Then it's got to come down. And then it's got to keep going down. And that's where the triangle comes into play. That's how I know that triangle is bigger, and I need the 11 to go in my second triangle. So I'm going to just change that a little bit. All right, we'll go back and put that in there and put my 11 so I can actually read it. Okay, so that's important. As always, that point is important as well, because I know that in the y direction, the velocity is 0, and I know I have some sort of time. Now, in past, if I were, stopping on the same level, if I was stopping right there, I would just double the time. But you notice I'm going beyond that now. So I can't just double the time. It's not really going to help me very much. I mean, I can, but it's not going to give me anything useful on my triangle. So we'll just worry about finding the time here. So that'll be the first thing that we do. So here we go. Let's start with our slope of negative 9.81, which I gotta jot in there for us. All right, so negative 9.81 meters per second squared equals VF minus VI over TF is TI. I know that this is repetitive, but the thing is, if you only have, two things that you're working with, it takes the pressure off because you know you're going to be doing the same things over and over again. It gives you a better chance of really kind of understanding what you're doing. At least in my opinion, it does. All right, so here we go. Negative 9.81 TF, instead of making everything a special example, don't you think? All right, so this time becomes turns out to be 2.55 seconds. So I'm going to write that in here. 2.55, that's really tough to read. 2.55 seconds. All right, that is the time to the peak of flight. And like I said, I could double it, but it's only going to get me here. And that is, that's not the whole way down. All right, so this is now where things are, oh wait, let me figure out delta y, because I can do that. I can do that. All right, so I'm going to figure out how high it goes. All right, so delta y equals 1/2. The base is 2.55 seconds. The height is 25 meters per second. And if I do a little algebra there, what do I find? What do I find? I get 31.8 meters. Well, this is actually really, really, really helpful for me because, of course, I had to get all artsy with my triangle here. Let me just redraw this a little bit. Bear with. We'll get it back to what we want. All right, so I started up here and I went on my way down, right? So think about it. This is now 31.8 meters. Here's my negative 9.81, right? Meters per second squared, like I had before. But now down here, I have 31.8 meters. Well, technically it's negative, and so is this one. This is a negative 11, right? But I know that my total, so this is on the way up. On the way down, delta y equals 31.8 meters plus 11 meters. So I can figure out the value, or I should say negative 31, negative 11, right? And so then I can figure out the total is negative 42.4 meters. That's how far it's going to fall from the peak of flight here all the way to the ground. So it goes pretty high. Alrighty, now the time. The time is a really tricky one. We have to be a little tricky with it. Otherwise, we're going to end up doing a quadratic equation, which, math teachers like, but I don't really care for doing. Neither do you, usually. All right, so from there to there is 2.55 seconds. From here to here, I don't know. That's something, right? Now, what we could do is we could say that this is TF, and that TI is 2.55, and we could subtract them TF minus 2.55, but that is going to lead you smack dab into the middle of a quadratic. So that is something that I personally would like to avoid. I don't like doing that. So what I do is I make a little trick and I pretend that I'm going to start over right there. I'm going to start over right there, and I'm going to figure out my time from the peak of flight to the ground. And the reason I'm going to do that is because it's going to take out one of the numbers and I'm not going to end up, because I'm going to have an initial velocity of 0, I'm not going to end up with a quadratic, which is a handy thing indeed. So I am going to take care of that. All right, so we're talking about just on the way down now. Just on the way down. Let me give myself a little breathing room in here. All right, so on the way down, negative 9.81 equals VF minus VI, TF minus TI. TI is 0 because I said it was. VI is 0 because I said it was. And I reset the axis. That is a tricky little thing. That should be TF equals VF. Great. And then, of course, I'm going to use my area under the curve. And then I'll substitute one into the other. So negative 42.4 meters equals 1/2 times 9.81, or negative 9.81, TF squared. As you can imagine, I'm substituting in for VF, TF. I just skipped a step because I'm getting tired. What can I say? All right, negative 84.8. Again, multiply both sides by 2. Don't multiply by 1/2. That makes no sense. All right, equals negative 9.81 TF. You're going to divide, or TF squared. You're going to divide by the 9.81. You're going to take a square root, and you're going to get a TF of 2.94 seconds. Now let's think about what we just found, because it's great. You guys are great at math, but someone's like, well, I don't know what that number is. All right, that is the number from here to here. All right, combined with your 2.55, which is from here to here, you now know the total time in the air. Ta-da! All right, so you're going to add those two up. I'm going to see if I can't go back. Here we go. So I got a little space here. So the total time in the air is going to be the 2.55 seconds for the way up, plus the 2.94 seconds for the way down, which will give me a lovely total of 5.49 seconds in the air, which is actually a very long time in physics. And we're going to put it right there. And now we're going to solve for the final answer. Delta x will be 43.3 meters per second times 5.49 seconds. And I get 237.8 meters, give or take, depending on your rounding. Okay? So hopefully that helps you out. Hopefully that helps you out. The other ones, I'm not as much of a fan of the other questions there. If you are struggling and you are wondering what to practice, let me point out where you have some extra practice in this book. Well, let's see. We've got on the very next page, on page 113, you have some extra problems with an answer written there. Okay, the first two are horizontals, and the last one is being launched at an angle. So if you're prepping for tomorrow's quiz, you'll want the ones launched at an angle. Or we have another handy-dandy bunch of questions and things on page 106 and 107. And those also have answers, but no work. So, you know, anytime it mentions an angle, guess what? That's a one that's launched at an angle. Anything that talks about just being horizontally dropped or no angle mentioned at all, that's a horizontal projectile. You can practice that one separately. All right, so hopefully this was helpful. Please, please bring me work if you have questions so I can see what you're struggling with. And I will see you tomorrow.